Alrighty, this final question is bringing us back to Unit 1, but with a Unit 4 twist. Evaluate the following limit. The limit as x approaches pi over 2 of 3 cosine x over 2x minus pi. So the first thing we always want to do when we try to limit is direct substitution. So I'm going to try that out. My first step, I'm going to see the limit as x approaches pi over 2 of 3 cosine x over 2x minus pi. That equals 3 cosine of pi over 2 over 2 times pi over 2 minus pi. 2 times pi over 2 in the denominator, that's just going to give me pi on the bottom. So it's going to be pi minus pi. Oh, I don't like what I'm seeing. 3 cosine of pi over 2, cosine of pi over 2 is 0. So 3 times 0, oop, I get 0 over 0. Oops. Before, we would have to do all kinds of manipulation of this, do some factoring, blah, blah, blah. But now, we know if we see 0 over 0, first I'm going to do a big X here, okay? Because I'm saying it doesn't equal 0 over 0. Nothing can equal 0 over 0. We don't have that. So I'm writing a big X. That's not what the limit equals. But I do know, because of L'Hopital's rule, the limit as x approaches pi over 2 of this will be equal to the limit as x approaches pi over 2 of the derivative of the top over the derivative of the bottom. And so I want to find what's the derivative of 3 cosine. That's going to be negative 3 sine x over the derivative of the denominator. Derivative of 2x is just 2. Derivative of negative pi is 0, so it's going to be this. Now, why did I do that? Well, that's because we can apply this rule. This is not the quotient rule, right? The L'Hopital's rule is not the quotient rule. Because we're not finding a derivative, we're finding a limit. And so now I can use direct substitution. Negative 3 sine of pi over 2 over 2. Sine of pi over 2 is 1, so it's negative 3 times 1 over 2, which will give us negative 3 over 2. And so we found, in the end, by L'Hopital's rule, that the limit as x approaches pi over 2 of 3 cosine x over 2x minus pi is equal to negative 3 over 2.